Hi everyone, welcome to this video. This is part 3 of the series on functions for AS Maths, and we've talked about in the previous videos about the definitions of function, domain, range, one-to-one function. In the last video identified the range of a function in simple cases, so we've done that. So this video I'm going to be focusing on the composition of functions, the composition of function or the composite function. So in the second bullet point here, it talks about find the composition of two given functions. So we're just going to focus on what the composite function is. Okay, so what is a composite function? So simply, it is the result when we combine two or more functions. So we do one and then we do the other. So let's visualize this in terms of machines. So we've got a function here, and this is the add one function. It's a pretty simple function. It says f of x is x plus 1, which means that any number that we put in to this function here spits out a number one more than came in. Pretty simple function. Now this second function here is the squaring function, which means any number that we put into this function here spits out the square of that number. So if we put 3 in, it spits out 9. A composite function is when we apply both functions. So first we add 1 to the number, so that's first, and then second stage we square that number. Alright, so the order that we do this in is important. Alright, so let's say in this example here, just to show that if we started with 2 here, we end up with 9 doing it in that order. If we did it in the other order, so if we reverse these two around, if we put in 2 to start with, square it, we'd get 4, then we add 1, we'd end up with 5. So the order here is important when we're doing composite functions. The way that we write these functions is like this. G of f of x, there's a lot of brackets going on there. I think it's nicer to look at it like this, g f of x. So that's the best notation that you can use when you're talking about composite functions. So that just means kind of looking from the inside out, that we've applied the function f of x first, and then we've applied the function g of x after that. Alright, so that is the definition and the notation of a composite function. So in this example, we've worked out what g of f of 2 is. So we've done f of 2. Remember the f function was we've added on to the 1. So f of 2 is 3. So g of f of 2 is just g of 3. So notice that we do the inside bit first. And then g of 3, the g function here is square it. So 3 squared, so is 9. So that's what it looks like in notation. If we look at the algebra here, g of f of x, again doing the inside first, the f of x function is just x plus 1. So I'm going to replace f of x with x plus 1. And g of x plus 1, we know g of x is just x squared. So whatever it is that we have here, we square it. So g of x plus 1 is just x plus 1 all squared here. So g of f of x, we've now defined this composite function here as x plus 1 all squared. So you can see that's true if we say g of f of 2. We know that we got 9 out of there, so if we say what's g of f of 2, rather than going through the intermediate step, I'm going to go straight for this one here. That's 2 plus 1 squared, 3 squared, which is 9. Notice the order makes here. If we have f of g of 2, so that we've reversed these two around now, f of g of 2. So g of 2 is, we know that g of 2 is just square that number there, so that's just f of 4. So we've just done this operation first. F of 4, we know the f function just says add 1 to whatever is here. So we get 5 when that comes out. So in algebraic notation, this is an important one. F of g of x, do this first. That is f of x squared. So you can see I've just replaced gx with what the function is for g of x. And the f function just says whatever we have here, add 1 to it. So f of g of x is x squared plus 1. So again, if we say f of g of 2, let me write it out properly. So f g2 like that. I'm just going to go straight and use this one here and say that that's 2 squared plus 1, which is 5. Alright, some quick examples. We've got two functions here. One's a linear function, f of x, and one's a quadratic function, g of x. F of g of minus 1. Alright, so I mean, the long way here is you could actually work out what f of g of x is and substitute minus 1. We're going to do that in part C. But I think to start with, it's easier just to work out what g of negative 1 is. So substitute -1 for x in this equation here. So we do that and we get 3. Alright, and then f of 3, just substitute 3 into this equation here. 2 times 3 plus 1, so we get f of g of -1 is 7. G of f of 0.5. So again, do the inner function first. Kind of think of brackets around it like that. So substitute 0.5 into the f function. 2 times 0.5 plus 1 gives us 2. So then we've got g of 2. And now we substitute 2 into x into this equation. 2 squared minus 2 times 2, we get 0. F of g of x. Alright, so f of g of x. So we replace g of x with what it actually is, x squared minus 2x. F of x squared minus 2x. Just remember, f of x equals 2x plus 1. Whatever it is that we have here, we just substitute there. So in this case, we have to substitute for x, x squared minus 2x. So we just replace x in this equation here with x squared minus 2x, which gives us this expression here. Expand the brackets, and we get 2x squared minus 4x plus 1. G of f of x, reversing the order here, so g of f of x. What's f of x? F of x is 2x plus 1. And remember the g function. The g function says square whatever it is that's there, and then minus 2 times whatever it is that's there. So square whatever it is that's there, 2x squared, 2x plus 1 all squared, minus 2 times whatever it is there. This is probably the trickiest part of functions here and getting started. So then we have to expand all of this out, expand the brackets, subtract those, and we end up with 4x squared minus 1. And the last one, f of x. So a function of a function, same process. F of x, do the inside first. So f of 2x plus 1. And so this, the f function says 2 times whatever is in there plus 1. So 2 times 2x plus 1 plus 1. Expand the brackets and simplify 4x plus 3. Okay, a little bit harder now. We've got h of x and k of x, two different functions here. Find k of h of a half. Again, I wouldn't recommend working out what the composite function is, then substituting a half in. It's a lot of the time it's much easier to work out what h of a half is first and substituting that value into the k function. So h of a half. So in other words, we're substituting x equals a half into there. So 2 over a half minus 1. There we go. And that is 2 over negative a half, which is negative 4. So k of negative 4, we're just going to substitute negative 4 in there for x. So 1 plus 2 times negative 4 squared gives us 33. Okay, so for part B, we want h of k of x. So we want an algebraic answer here to what is the composite function. Remember to start from k of x. So we're doing k of x first, followed by h of x. So h of k of x, replace k of x with what the actual function is, which is 1 plus 2x squared. And the h function just says 2 divided by whatever it is written there goes there. So in this case, we've got 1 plus 2x squared that we replace there. Okay, that's the crucial part in forming these composite functions, is being able to see if h of x is 2 over x minus 1, then h of this is 2 over this minus 1. Okay, so once we've got that, it's just a matter of the bottom line simplifying. 2 over 2x squared is 1 over x squared. Part C, solve h of k of x is less than or equal to 1. Alright, so 1 over x squared, we've just worked this one out, is less than or equal to 1. If I multiply both sides by x squared, we're saying what are the x squared values that are greater than or equal to 1. This is back to quadratic inequalities a long time ago, and that's x values obviously greater than or equal to 1 or less than or equal to minus 1. And you could draw a graph if you wanted to. What's our x squared values? So if we do y equals x squared, what are the values of x squared where they're greater than or equal to 1? And you can see from the graph here, that would be 1, that would be negative 1. So when is the graph above that line? It's there and there. So greater than or equal to 1, less than or equal to minus 1. And the last question says solve h of x is equal to 1. Alright, so we've got h of x. So let's do that. H of x. So h of 2 over x minus 1. So again, we replace the h function with 2 over x minus 1. There it is there. So we just 2 over something minus 1, whatever it is there. So now we just got to do a bit of algebra magic. Common factor on the bottom line from here to here. Simplify the top line. And then we've got 2 divided by this fraction here. turn it upside down and multiply, so 2 times x minus 1 over 3 minus x. A little bit tricky, you've got to know your fractions to be able to do this well. Expand the top line, so we get 2x minus 2 over 3 minus x, and we wanted to solve that equal to 1, so we've multiplied both sides by 3 minus x, we've collected the like terms, and the answer is x is 5 over 3. This is an example I've seen a few times in the exams, a function ax plus b, a little bit of funky notation here that you might see, f colon x, and this little symbol here, it's just exactly the same as saying f of x. And f of negative 1 is 1 and f of 2 is 7. Find the values of a and b. So to work this one out, we're just going to substitute x is minus 1 into x for this function here. So you get negative a plus b, and we know that that's equal to 1. And f of 2 is 7, so we substitute x equals 2 into the equation. So 2 times a plus b is equal to 7. So we've got some simultaneous equations that we can solve really simply. Just have a look at these two. Subtract the equations, we've got a equals 2 and b equals 3. Second part of the question says solve f of x equal to 1. So f of x, well now we know what a and b is, and we know the function is 2x plus 3, makes it easier. F of x, so f of 2x plus 3, so we'll put 2x plus 3 into here, so 2 times 2x plus 3 gives us 4x plus 9, and we're trying to solve when is that equal to 1. Simple linear equation to solve gives us x equals negative 2.